All right. So today, let's look at week 9's topics. We're going to be covering the same big concept as the last week that we did and the week before that, which is problem solving and data analysis. There's a lot of math concepts that are under this topic. It's about as big as the very first topic that we looked at, Heart of Algebra. So let's see. Today we're going to be looking mainly at graphs and functions, and that's really it. So different types of functions and then reading graphs. So with graphs, you'll normally have to look at different parts of the graphs to identify a value that they ask you to find, or sometimes they give you values to match up with a graph. So they can kind of go both ways, right? So they can give you a graph and ask what it says, and then they can also give you what something says and then ask which graph says it, right? So they can do both. You're going to be looking mainly for a few key features. For linear graphs, you're going to be looking at the slope, which you calculate by doing the rise over the run. So for rise over run is kind of the layman term of it, but really what you're doing is getting 2 points. Here they give the terminology of x1, y1, and x2, y2. Now to find the slope, you do y2 minus y1 divided by x2 minus x1, as shown over here. And then you also want to look out for the y-intercept, which is called b in this case because of how the most commonly written format is. The most commonly written format is y equals mx plus b. Sometimes you may see y equals mx plus c, but the point is that constant number that's being added to the end is your y-intercept. So when the function starts at 0, 0, then the b equals 0, right? So all this means is, all the y-intercept is that vertical line, the y-axis, when the line crosses the y-axis. Now this can happen only once. The x-intercept can happen as many times based on the type of graph, right? Based on the number of degree that the equation has. But the y-intercept can only happen once for a function, because if there were 2 y-intercepts, then that violates one of the main rules of a function, which is that you can't have 2 y's for the same x. So you can't have 2 outputs for 1 input, right? So y-intercept, it's going to be 1 point only, and then it's where x equals 0. So there's multiple ways you can figure out the equation. Sometimes you'll be given values to figure out an equation. One is if they give you the slope and the y-intercept, this will be the easiest method. You do y equals mx plus b. M here is the slope. M is always going to be used as slope when you're talking about linear equations. And then b here is the y-intercept. Sometimes it can be called c, but again, here they call it b. And then the second equation that they have here, you may have noticed this, you may recognize this, which is the point slope format. You're given normally, so here it says you're given a slope and a single point on the line, but in school what you've probably done and what you'll probably be expected to do on the SAT is you'll be given 2 points, you'll have to find the slope, and then you'll also have to use one of the other points to set up the point slope. Now if you solve the point slope and then make it look like the y equals mx plus b, you will have both of those equations. So when you're given 2 points and you're not sure what format the answer is supposed to be in, probably write it out in point slope, and then if it doesn't match up with anything, try solving it for y or isolating the y, and then you'll find the answer. So that's how you'd normally do that. Okay, so again, kind of reviewing, the slope is normally something that you're expected to calculate. It's calculated by doing rise over run, and then the value of a function is the y-coordinate. If you think about it, it says y equals the function. So whatever the function is what y is, so the y value is going to be the value of the function. The x and y intercepts are where a function intersects at the x or y axis. Now, the x-intercept, there can be multiple. So, for example, normally quadratic functions, at least on the SAT, will have two x-intercepts, or as you may also know them, two solutions. And then the y-intercept will be only one, and it's where x equals 0. So you can do that by plugging in 0 for x, or you can do that by simply looking at, for example, if you had a linear equation, it's that n constant. Okay. Let's look at our first practice problem here. The graph at the left in the SM plane approximates the average mileage m in miles per gallon that Denise's pickup truck gets when she drives at a speed of s miles per hour. What is the best interpretation of the maximum point on the graph? So I'm going to go ahead and release the poll, and you can enter your answers in as you get them. Okay. Concept: graphing quadratic equations. You don't actually need to know how to graph equations. You don't need to know how to graph quadratic equations. Just know a few key things. If there is a negative sign, if there's a negative sign in the beginning, then you have a parabola that's pointing down, right? And then the positive or negative b, or well, it is, you can call it a b value, right? The positive or negative b value, I believe it's actually called the c value, for quadratic equations, talk about the y-intercept in this form. So just kind of looking at that and seeing the ways that the parent function, which is x squared, has been transformed. So here in this equation, there's a negative sign, and there's also a 2, which stretches the function vertically. And then there's the 3, which is going to shift it up or down. Again, I think we covered this in one of the earlier classes, so I won't go too much in depth for that. And again, it says the most common scenario modeled by quadratic equation is projectile motion. You don't need to know anything about projectile motion. They'll give you an equation. All you really need to know is how to solve an equation. Here they talk about exponential graphs. So exponential graphs have multiple parts. Don't really need to know anything. You just need to know that if the x part of it has a negative sign, then you're going to have the function flipped across the y-axis. If the a, which is still the coefficient being multiplied to the base, has a negative sign, then it's going to be flipped across the x-axis. So it's going to be inverted. And then you have the base, which if it's that indicates growth or decay. There's not much else. I mean, the 3 here is greater than 1, so it'd become decay. And then, or if it's greater than 1, it's growth. If it's less than 1, it's decay. Does anyone have any questions about exponential functions? Okay, so if not, I'll go ahead and move on to the practice problem. Here you have a graph that talks about someone's jump height, so where they are in a jump, over a period of time. The graph at the left in the TH plane shows Braden's height in inches above the ground, t seconds after he jumps. What is the best interpretation of the t-intercepts of the graph? And if you could enter your answers into the poll, please. Okay. So, most of the people who answered picked answer choice C. So, let's look at, so that is the correct answer. Answer choice C is correct, but also another picked answer choice was answer choice B. Let's look at both of those, and I'll also talk about very briefly why A and D are incorrect. So, Braden jumped 0.6 feet into the air. Well, clearly he jumped more than just 0.6 feet. Right, so he jumped up to 24 inches, so we just know that's wrong in the first place. And then also you have the 0.6 is not something that's kind of discussed in terms of that. The t-intercept has nothing to do with the height, really. It has more to do with the x values. So whenever you're talking about the intercepts, you're normally dealing with units that are on that axis. So here we have the unit of seconds. Your answer is probably going to be in seconds. So you can normally eliminate all the other answer choices. Okay. And then the answer choice D talks about how Braden reached the peak of his jump after 0.6 seconds. Well, he reached the peak kind of in the middle around 0.3 seconds, if you look at the graph. But at 0.6 seconds, he was at the ground, so he was definitely not at his peak. Let's look at why answer choice B is incorrect. Braden jumped 0.6 times per second. Now, you don't really have any data for the whole second. If anything, he at least jumped one time per second, right? If he jumped once in less than a second, then clearly he's jumped more than 0.6 times in 1 second. So you can eliminate it that way, or you can also say that the 0.6 times per second is not something that is talked about in the graph. But regardless, he's definitely jumped more than 0.6 times because he's had a whole jump in less than 1 second. That leaves answer choice C just through the process of elimination. But also you have to think about what this equation, what this graph is modeling. It's modeling his time in air. So it's talking about the jumping period, but jumping period is really the time in air. So the whole equation, the graph, lasted for 0.6 seconds, which means he was in the air for 0.6 seconds. Also, why does that relate to the t-intercepts? The t-intercepts are where y equals 0, where the height equals 0. If the height equals 0, that means he's at the ground. So anytime other than those two specific points, he's been off the ground. So that's how answer choice C also relates to the t-intercepts, and it's also a correct statement. So you can pick answer choice C. Okay, so does anyone have any questions about this problem? So this is a projectile motion. Well, it's not necessarily projectile motion, it's just talking about gravity, but this is what is meant by a projectile motion problem. Okay. An object is launched at a velocity of 7.9 meters per second from a height of 2.4 meters above the surface. The height of the object, f of t, at time t can best be modeled by which of the following types of equations? If you can just go ahead and enter into the chat what you think the answer is. So is this function a quadratic, linear, or exponential? Okay, so people are saying that it's a linear function. Now, this is just talking about something that we talked about earlier, which is that projectile motion is normally modeled by quadratic functions. Okay, so why would it not be linear? Well, if you think about it, what shape happens? So let's kind of draw a picture here, right? So say that's the ground. Then you have like a cannon of some sort, maybe. Normally it's like a cannon or something that shoots, and then shoots out the cannonball. It's going at 7.9 meters per second. Let's just say that height right there is 2.4 meters, right? What kind of pathway is it gonna take? It's gonna take a pathway that's kind of like that, right? So if it was linear, this is kind of how it would look like. It's going to go and go and go and go and go and go. It's going to keep going forever. That's not how it would work, just because we are dealing with gravity. And then if it's exponential, well, that's going to go up at a different level. Definitely will not be the right answer. And then also the other form of exponential is decay. So if it were to be decay, it looks more accurate, but still it doesn't model the projectile motion's quadratic function. So now I saw something in the chat about how if it was shot straight down, that it would be a linear function. Now, even then, it would not be a linear function. And here's why. For something to be linear, the rate of change cannot be changed. When you're dealing with things that are being thrown as projectiles in any way, shape, or form, you're dealing with, at least with respect to the SAT problems, for the SAT problems, you're dealing with gravity. And what that's going to do is it's going to change the speed of something when it's being shot down, shot upwards, shot straight across. Doesn't really matter. It's going to change its speed. It's going to change its velocity. So if it starts at like 7.9 meters per second from like 2.4 meters, it's probably not going to change too much, but it'll still change to about maybe 8.2 meters per second or something like that. Right, so all I'm saying is that if you're rated for any function to be linear, the rate of change has to be constant. This is height in terms of time, right? So this is a height versus time graph. The rate of change is the velocity. And if the velocity changes, then it's not a linear equation. And then it's not going to be an exponential equation because it's not like the velocity is being halved or multiplied by some factor. It's just being slowly added on. So then it's going to be a quadratic function. Right, it has more to do with how the equation is written, but really the main concept is that projectile motion problems are going to be quadratic functions. Okay, so does anyone have any questions on how I did this problem? All right, so if not, I'm going to go ahead and move on to the next question. The mean number of students per faculty Y at the university can be estimated using the equation y equals 0.13x plus 13.6, where x represents the number of years since 2005. And it has to be between 0 and 10. All that means it starts at 2005, and then it goes all the way up to 2015. Which of the following statements is the best representation or interpretation of the number 0.13 in the context of this problem? Okay, so I'm going to go ahead and end the poll now. Okay, I'm going to go ahead and end the poll now. So, out of the people who answered, answer choices D and C were picked. A and B were never picked. So let's look at. So the correct answer is answer choice D. So let's first talk about very briefly why A and B are incorrect. Remember in that format, right? In the y equals mx plus b format, the number, the coefficient in front of x is the slope. So the 0.13 is gonna not be any one unit. It's going to be a rate. It's going to be the rate of y unit over x unit. So if you look at the y unit, it's the mean number of students per faculty, and then the y unit is the years. Or no, x unit is the years. So it's going to be mean number divided by years. So mean and year, they all have to be there. Here it only uses the units of mean number of students per faculty member, and it talks about specific moments in time, which is again not something that the slope talks about. The slope is something universal for the whole line. So you can eliminate answer choices A and B. The only two that talk about a change of some sort, an increase or a decrease, are answer choices C and D. Now, why D is correct is the fact that it says increase rather than decrease. Now, I know that it may seem like, okay, if you're multiplying by a number that's less than 1, shouldn't it be decreasing? No, because in linear functions, anytime you have a positive slope, no matter how big or how small, it's going to always increase. And negative slope, no matter how big or how small, is always going to decrease. Right? How quickly it may increase or decrease, that's where the number, the size of the slope matters. But the only thing that matters for if the function is increasing or decreasing is the sign of the slope, which is positive. So that brings us to answer choice D. I feel like what may have confused people is the 0.13 is less than 1, and when you deal with exponential functions, that is normally associated with a decrease because that's decaying. It's giving you a number that's going to be less than what you started with if you multiply by 0.13. But again, remember that you're adding it to this 13.6 over and over again. So no matter what, your value will keep increasing just because it's a positive slope. Now, if there was a negative sign and it's a negative 0.13, then it's going to be a yearly decrease. But again, the key thing is it talks about change and it uses a sign. Does anyone have any questions on this problem? All right, so if not, I'm going to go ahead and move on. Which of the following is the best interpretation of the number 13.6 in the context of this problem? Again, it's talking about the same equation, y equals 0.13x plus 13.6. Go ahead and enter your answers into the poll. Okay, so I'm going to go ahead and end the poll now. All right, so I'm going to go ahead and end the poll now. So out of the people who answered, most people picked answer choice A. Also, answer choice B, I believe. So let's look at what the correct answer is. Which of the following statements is the best interpretation of the number 13.6? Now, if you think back again to the form of the function, it's y equals mx plus b. What is that b talking about? The y-intercept. The y-intercept is the initial value when x, which is the years, well, I mean more specifically, the years from (2005), right, equals 0. So that means the y-intercept for this problem is the value at 2005, or in 2005. And if you look at the question here, the 13.6 is the b, so 13.6 is the value in 2005. And since it's talking about the y, right, the 13.6 is the y coordinate when x equals 0, what's the unit of the y coordinate? It's the mean number of students per faculty member. So it's 13.6 students per faculty member in 2005. So what matches up with that here in answer choices C and D, they talk about increase and decrease. That has nothing to do with the y-intercept. And then it talks about the estimated mean number of students per faculty member. That the units match up there. Then let's look at the second part, 2005 or 2015. Well, we already said that it's when x equals 0, and x here is the years from 2005. So B is the value in 2005. So then the answer choice that's correct is A. Okay, so does anyone have any questions on how I did this problem? Okay, so if not, I'm going to go ahead and move on to the next question. Again, here's another question. You can just enter this into the chat. The population of an Asian nation doubles every 34 years starting in 1900. The population of the nation after 1900 can be modeled by which of the following types of equations? So exponential function. Yes. Population growth, interest rates, a lot of those things that grow exponentially. I know that's kind of a weird way of thinking about it, but almost everyone can identify what grows exponentially, right? We use that word in a lot of everyday concepts. So anything that grows exponentially is going to be exponential. Also, anything that decays exponentially is going to be exponential, but that's a little bit harder to understand. Pretty much anything that increases by 8% rather than a set value, or increases by a multiplying factor or dividing factor rather than a set value, is an exponential function. So yes, it's an exponential. Okay, so determine whether y equals 10 times 4/3 to the x represents exponential growth or exponential decay. So again, this is more of a just understanding definitions. Exponential growth, that's a graph that looks like this. Exponential decay, that's a graph that will look like this. So again, the relative steepness of the line should be about the same. Just wasn't able to write it the same way. But which one do you think this function is representing? Do you think it's representing growth or decay? So it's going to be growth. So why is it going to be growth? Well, again, the key rule, the rule that we have to follow, is the base here. That's the base. If the base is greater than 1, then that's a growth. If the base is less than 1, then that's a decay. So 4/3 is greater than 1, so it represents growth. So sometimes where this matters is if they're talking about population growth, you don't want to pick a graph that looks like this, right? If they give you a percent factor that you're multiplying by, then you know that if the percent is greater than 1, then it has to look like this. So just kind of understanding what that base number is and then what it will mean for an exponential function is kind of useful in finding some of the answers that the test may ask. Okay. Now let's just talk about, very simply, linear and exponential functions. There's going to be a lot of questions that talk about linear functions and exponential functions. And sometimes they'll throw some answer choices in that represent linear functions and not exponential functions. And a question, sorry? Okay, so they'll throw in some questions that talk about linear functions in exponential functions, right? So they'll have an example a setup of an exponential function. And then in their answer choices, they have 4 answer choices. 2 of them are going to talk about exponential, 2 of them are going to talk about linear. Now, almost always, one of those linear function answer choices is going to look very convincing. However, you have to know certain details that set apart one from the other. You mainly want to look at the units of the rate. If the unit of the rate is the y over x, or this specific amount of change over a specific amount of time, or whatever it is, then you're dealing with a linear function. And then whenever you're dealing with an exponential function, you're normally given rates like doubles, halves, triples, some kind of percent change, maybe just percent multiplying, things like that you're normally given. And then the most easiest method would be when you're just given the function and you can see that it's modeled like a linear or modeled like an exponential. So now I think doing some examples about this types of question will help. Okay. So here's one way they'll give it. They'll give you a graph with all the, it's not a graph, it's a table, it's an input table, input-output table. They'll give you this type of table with all the inputs and all the outputs that it produces, and then ask you to figure out, okay, what type of function is that? And then what is that function saying? So I'm going to go ahead and release the poll, and you can go ahead and enter your answers in as you get them. Okay, so I'm going to go ahead and end the poll now. So, most people who answered picked answer choice D. So, first off, that is the correct answer. So why is it that? Now, let's look at each answer choice and use the process of elimination again, and then I'll explain the more direct way of getting the answer. First, I'm going to just look at the answer choices to see which ones don't make sense. Linearly is the type of function they're talking about on question A, and then it says 30 every week. So it's talking about change in y and change in x. So the x is the week, change in y is the 30 part of it. The type of change that it says it is and the actual rate given matches up. So it can be a potential answer. Without even looking at the table, I can tell you that's a possible answer. And then answer choice B, the number of customers per week grew linearly. Okay, so again, it's saying linear. And then it talks about a rate that's in percent. And anytime you have a rate that's in percent, you're talking about exponential functions. So just without even looking at the table, I can eliminate answer choice B. And then answer choice C, the number of customers per week grew exponentially because the number of customers per week increased by approximately 30 every week. So it says it's an exponential, but then it gives you a rate that's like a linear rate. That doesn't match up. You can eliminate that. The number of customers per week grew exponentially because the number of customers per week increased by approximately 100%. So percent for a rate and the exponential, that part matches up. So now you can look at the table. Is it increasing by a set value each time? Or is it increasing by some type of factor? You can see here that if you add, so here it adds 30, and then the second time it adds 60, and the third time 120, fourth time it does 240, and then it does 480. Clearly it's not adding a set number. But now if you think about it in terms of multiplying, well, it's multiplying by 2, multiplying by 2, multiplying by 2, multiplying by 2, and multiplying by 2. And since this rate of doubling is consistent, then you can tell that this is an exponential function, and you can tell that its rate is doubling, which is 100% change or 100% increase, and it's doing that every week. Wait a moment. Oh, so let me go ahead and redo this problem here. I had completely overlooked one specific part. Again, this is something that almost any time you can overlook. It's the change here. It's not consistent. The change in the x that they give for the input is not consistent. So let's start again. So again, you can eliminate answer choices B and C. That's fine. And then let's look at answer choices A and D. Is it linear? Is it exponential? That's all you're asking. The change here is 30, right? The change here is 60. And the change here is 120. Clearly different changes. But also the change here is 1 week. The change here is 2 weeks. The change here is 4 weeks. Now, if you think about how linear rates are developed, it's going to be the change in y over the change in x. So let's look at this first set here. From 1 to 2, it increases by 30, and the weeks is 1. So it's a rate of 30. From the week 2 to 4, it increases by 60, and it's over 2 weeks. Rate is again 30. And then you have this last one here. It's going increasing by 120 over 4 weeks. So 120 over 4. So 120 customers over 4 weeks. That's going to be 30 yet again. So because that change per week, so you have to make sure that that change is for 1 unit change in the x, that change per week is 30. So that's a constant rate. So you can say that the answer is actually answer choice A. So D is actually incorrect because the values that they're giving for inputs is not increasing by a set number each time. Does anyone have any questions on how I solved this problem? Okay. Okay. This is a very similar problem to the last one, so I'm not going to work this out. Okay, so here's one where you need to set up the function. So I'm going to give about a minute and a half to answer this question. You can go ahead and enter those answers in as you get them. Okay, so I'm going to go ahead and end the poll now. So people picked answer choice D, which is incorrect. So it's one of the answers that you do get when you're solving the problem. Oh. Let's see if I can get that. Okay. So the first thing you're going to want to do is set up an equation, the linear function. So I'm going to call that T1. That's the old program, or that's the new program. Let me set up the old program first. So it starts off with a 0.05, and then each time it takes twice as long. And that 0.05 is for the first n equals 1. So you're going to have to make that 1 there, an n minus 1. I will send out probably a document or something that talks about how you set up equations. Normally this is not something that you do have to do on the test. It's normally set up for you, so you don't have to worry about it. And then T2, you can talk about it as a linear function. So it's T1, the first value, the n1, is 0.8. And each time it takes 0.6 longer. And then again, you have to do the n minus 1 because you're using for your intercept there, and your initial value here, the n equals 1 part. So then if you plug in your values, you get that the new program does 5 microseconds, and then the old program does 6.4 microseconds. If you plug in 8 to both of these equations, you get those two numbers, and then you have to know that the question is asking for how much longer. So then you would have to do the 6.4 minus the 5 to get you the answer of B. So I did kind of rush through that problem. So does anyone have any questions on that? Okay. So I didn't realize that I had went over time, but pretty much all the problems that are after this are thinking about two key concepts. Linear, you have a set value that's increasing by for each increase in x. And then for exponential, it's a multiplying factor or it's a dividing, or it's a percent change of some sort. So that's the key takeaway from all those problems. Does anyone have any questions left? Okay, so if not, I'll go ahead and